All right, 3.4 is just adding on to 3.3 with some more theorems, this time about perpendicular lines. The first one here is how to find the distance from a point to a line. So in geometry, this is defined as the length of a perpendicular segment from the point to the line. So that's important. In your brain, you can say, well, that's the distance right there, right? From A to whatever Q. But it's not. The distance is defined as the length of the perpendicular segment. So it has to go straight down and make a right angle. If you do this, it's wrong because of the definition. So you're trying to find the distance from point A to line BD. They're perpendicular. Right here's your little symbol saying that. So your distance is the distance from A to C, or AC. So use the distance formula. So square root of negative 3 minus 1 squared plus 3 minus negative 1 squared. So that gives me square root of 4 squared plus 4 squared. So square root of 32, which is some number. Let me find it in the calculator here. Roughly 5.66. All right, so a problem just like that one. Find the distance from point E to line FH. Go ahead and try it. It's a pause the video, get your answer, and then come back. So they're perpendicular. So we use from E to J, or E to G, sorry. So square root of negative 4 minus 1 squared plus negative 3 minus 2 squared. So square root of 5 squared plus 5 squared, so square root of 50, which is roughly 7.07. All right, so to construct again, this time perpendicular lines. Okay, now we're going to construct a perpendicular line. So again, I want to have a line and a point, not on a line, just like we did before. And a point right here is fine, doesn't matter. Point P. All right, so now what I'm going to do, you grab your compass, and you want this to be a little bit longer the distance from P to the line. So like right there is fine. I'm going to put the compass on P and draw an arc that goes to the line twice. Okay. So you can see the little intersections here. All right, next up, you're going to put your compass at the first intersection point right here. Now put it at point B. You see right here how it lines up nicely. And there is your perpendicular line. All right, so a perpendicular bisector of a line segment is the line end that is perpendicular and goes through the midpoint of the line segment. So that's important there. To be the perpendicular bisector, it must first have a right angle, and it must cut this in half because it goes through the midpoint. And we're going to construct that one also, which we've already kind of done this one. We did the midpoint construction way, way back. That is the same construction. The only difference is this time you connect the arcs instead of putting the midpoint on. But let's look at it again real quick here. Okay, for our last one here, we're going to do the perpendicular bisector, which as I mentioned, we already did this before as midpoint. So you get a segment. Let's make our segment real quick here. Get your endpoints. What you want to do is move your compass to be, a little more than halfway or whatever. That should be good. Put it to one endpoint. You're going to make your arc. So let's go like this. Pick it up. Other endpoint. Same arc. And before, we would go right here and say, there's the midpoint. But this time, we're actually going to line these up and just draw the line down. And there is your perpendicular bisector. So some more theorems you can use here of your proofs. So you have the linear pair perpendicular theorem. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular, which should be kind of common sense. If you have these lines and these angles here are marked as being congruent, that's a straight line. They have to be 90 each. It's kind of obvious. So if you're in a plane here, if a transversal is perpendicular to one of two parallel lines, then it's also perpendicular to the other line, because that would be a right angle also, because corresponding angles. And this kind of goes the same way here. If you have two lines that are perpendicular to the same line, then those two lines are parallel to each other. So here, M and N will be parallel because they both make right angles with P. Again, because of corresponding angles. So we have to determine here which lines, if any, must be parallel. So since P and Q, which are right here, since they're perpendicular to line S, which is right here, that means that P and Q must be perpendicular. So we know that. And since lines S and T, these two, are also both perpendicular to Q, because there's right angles, that means that they have to be parallel. So S is parallel to T, and P is parallel to Q.